Semiconductor Industry Association's public webinar series, where we address current issues impacting the global semiconductor industry and market. My name is Falani Noog, and I am the Director for Industry Statistics and Economic Policy at SIA, and I'll be your host and moderator for today's webinar. As Congress considers funding domestic semiconductor research, design, and manufacturing, a new joint study by SIA and Oxford Economics analyzes the positive impact of the semiconductor industry on the American workforce and how federal industry incentives will increase domestic jobs throughout the economy. The report, entitled Chipping In: The Positive Impact of the Semiconductor Industry on the American Workforce and How Federal Industry Incentives Will Increase Domestic Jobs, finds that the U.S. semiconductor industry is essential to the U.S. economy, significantly contributing to U.S. GDP, stimulating jobs, and paying income to workers. Here to delve more deeply into the report conclusions and numbers are the two lead authors from Oxford Economics, Mr. Michael Reed and Mr. Hamilton Galloway. Mr. Michael Reed is a senior economist at Oxford Economics. Mike joined Oxford in 2015, bringing with him an extensive background in labor economics. As a member of the U.S. Economic Impact team based in Oxford Economics' New York City office, he is responsible for producing customized research, analysis, and modeling services for a range of organizations. Prior to joining Oxford Economics, Mike spent nearly a decade analyzing regional economies as an economist for the U.S. Bureau of Economic Analysis within the Regional Income Division, and before that at the Center for Labor Market Studies. Mike holds a master's degree in economics and a bachelor's degree in economics, both from Northeastern University in Boston. Welcome, Mike.
Thank you. Thanks for having me.
In addition, we have Mr. Hamilton Galloway, who is head of Consultancy Americas at Oxford Economics. Hamilton joined Oxford Economics in 2014 as head of U.S. Consultancy, a team focused heavily on developing quality customized research, analysis, and impact modeling services for a range of private and public organizations. Prior to joining Oxford Economics, Hamilton worked nearly 7 years as an economist, senior consultant, and manager at Economic Modeling Specialists International, EMSI, a data and analytic company based in the US. His expertise spans a range of economic impact and regulatory issues, covering trade, wages, salaries, taxes, workforce, and economic development. Welcome, Hamilton.
Great, thanks for having me.
Sure. Mike and Hamilton, I'd like to sort of keep this as sort of informal as we can, since it's just us on the webinar. I know you folks have done there are various parts of the report findings that we want to delve into and highlight. But before we do that, perhaps we should just give a little bit more background on the report and the approach that was taken in the report. Let me go ahead and share my screen. I can provide a little intro. So this was obviously something that we wanted to delve a little bit more deeply in, that is the jobs impact of the semiconductor industry domestically, because of obviously what is going on in Washington, D.C., the emphasis on sort of building back better, the Biden administration's efforts on that part, and obviously, of course, as well on the potential impact of CHIPS Act incentive funding for the domestic semiconductor industry. So the report really looked at a number of things. One, wanting to figure out what is the current impact, both in terms of jobs, direct and indirect and induced jobs in the US economy of the semiconductor industry. Also, what is the GDP impact in the United States of the semiconductor industry? And also, of course, what is the wage impact, and how is the semiconductor industry impacting, workers, and what's the worker profile of your average semiconductor worker? So a lot of that is contained in the report. Highly recommend folks going to the report, which was released yesterday. It's on the SIA website at www.semiconductors.org. And so the report is quite timely for many of these reasons, especially given sort of the Congress's efforts to consider funding for the industry. So it's quite timely. So why don't we go ahead and go to the next slide and talk about the specific objectives of the report.
Great. Yes, thanks, Falon. When we're looking at the specific objectives, and Falon gave a great introduction of kind of the CHIPS Act and the purpose behind the report, in order to get to the types of analysis of understanding that the economic and workforce implications associated with the CHIPS Act, we really set out three key research objectives. One is to establish that baseline, understanding a lot more of what's going on currently within the semiconductor industry, and calculating the current benefits and value that's being generated through the industry's activities, and establishing that baseline for 2020, then using that baseline, that foundation, to start understanding what the future implications of the incentives programs that are offered through the CHIPS Act would actually drive for economic value and be part of a U.S. recovery down the road. And then using that context, that background and information, really start to distill and understand what the socioeconomic and socio-demographic effects are actually associated with that incentive and that drive in economic recovery and economic growth and expansion within the semiconductor industry. And so we would do that by looking at some of the other aspects of labor force and industry and business composition that's associated with not just the direct production of semiconductors, but also all of the upstream, that supply chain contribution to the production and the output of chips in the US. And Flan, you want to go to the next slide? And to capture this, we use what's called an input-output model. And really what an input-output model is an accounting framework that traces and tracks economic flows. So the model itself is something that is derived from the Bureau of Economic Analysis using their input-output tables that looks at the upstream, that supply chain contribution to chips production, that value-added component that goes into producing chips, and everything from the inputs of components and parts and the purchase of machinery to also all the professional services and other services that go into both the R&D, the design, and the production of chips themselves. So we use that in order to capture and calculate what those supply chain effects are. And then off the back of that, we're also looking at the value that's generated through the wages that are paid to workers, both within the semiconductor industry, but also all those upstream industry sectors that are supporting or being supported through the production of semiconductors. And how people go out and spend those wages in the economy by purchasing homes, purchasing cars, going to the mall, or getting haircuts and all of that, creates an additional round of multiplicative benefits within the U.S. economy that's tied back to the economic activities of the semiconductor industry. So we're using that to create that foundation, that 2020 baseline, and then we're also using that same type of approach to extend the perspective of what the impact of the CHIPS Act would be down the line and in the future, while also incorporating a lot of the additional components of construction and other capital investment that be associated with that.
Yeah, and I would just add here, I think you mentioned using BEA input-output tables, but I also would mention that, the foundation for the direct jobs that we used was government data, the Bureau of Labor Statistics data. But we also worked very closely with our member companies because we had to refine the data a bit from what the government provides, knowing what they provide and what they may often miss in some of their data gathering. And there is a major component of our industry that we wanted to be sure that was captured in the direct jobs number, which was, of course, our fabless design establishments, which are often not captured by the BLS. So we had to work very closely with our companies. So I appreciate member companies who were able to complete our survey. And that was another component of the work that we did here, was direct outreach and input from our companies to be sure that we were able to capture all the direct jobs that are out there in the industry. And so we're very confident and feel very good about those direct numbers that in 2020, that, as Hamilton said, are the basis for deriving future and upstream and downstream numbers.
And without belaboring the point too much, I think Flan is kind of skirting the process that we went through in order to get to that. It took several weeks and a lot of back and forth and a lot of engagement. And I would like to reiterate, we were very much appreciative of the input provided through the SIA membership. It was a very exhaustive process, but on the same side, I think we feel very, very confident about the numbers that have come out for the direct jobs that are going into this.
Next slide.
Next slide, please. Yeah.
Yep.
So I talked a little bit about the direct and the indirect and the induced effects that are tied through this input-output modeling framework. But what we do off the back of this framework is we also distill the effects looking through three different channels of impacts. And these are the gross value added to the contribution of GDP. So this is the value added contribution to GDP that we tie back to the semiconductor industry. We're looking at the employment. So this is a headcount of workers that are tied to the production of chips in the semiconductor industry overall, as well as the income. So this would be the wages and salaries that are paid to workers. And then just to add another layer of detail, we're breaking these results out across industry sectors because we're tracing these flows back up through the industry supply chain, and then as well through the spending of employment, or the spending of wages and salaries by employees and elsewhere in the economy. So we have a very, very detailed look of these three channels of values across a lot of different industry sectors. And to the next slide.
All right, so now let's even delve into the numbers. So yeah, so these are the actual current day numbers, right, Hamilton?
Yes, absolutely. So
okay.
when you start to take all this detail, all this information, and these connections between industry activities up through the supply chain, the spending of wages, salaries by workers, and then all the massive direct impacts associated with just the production, the design, the R&D of chips themselves, and you boil it into some big high-level figures and numbers. This is what we end up seeing. You see about 1.85 million US jobs are supported or contributed to by the semiconductor industry. And this supports nearly $250 billion of US GDP. And this is just 2020 alone. So we're looking at the economic activity that's taking place as of last year. But this is coming off the back of actually quite a bit over 250,000 domestic workers in just the semiconductor industry itself. That would include the R&D, the design, and the manufacturing activities, among other semiconductor industry activities that are just directly within the industry sector. So when we start looking at these ripple effects that extend out and looking at the indirect and induced, you can see that the impact is quite large. And a lot of that extends from all of the economic activity that gets fed into both the R&D design and the production of chips themselves, and what that actually means. We'll talk a little bit about some of the other components in another couple of slides, but Fuad, I didn't know if you had any other thoughts and some other high-level perspectives you wanted to share on any of this as well.
Well, I know we'll probably get into this later, but I think compared to a lot of other industries, the upstream and downstream induced impacts tend to be pretty high, right? Compared to a lot of other industries. I know we'll talk about the multiplier, but can you talk a little bit about, sort of what leads to such high both upstream indirect and downstream induced numbers for the industry comparatively?
Yeah, absolutely. Because, and that's a great question. So because the industry itself is very capital intensive, and even the labor that's associated with that capital intensity is quite large. There's a lot of components that are going into the production of a chip. And I know I'm probably speaking as a bit more of a neophyte in the industry, and everybody who's an industry expert saying, yeah, there's a lot of components that go into making a chip. What we're doing is we're tracing all of that value that's ultimately feeding into the design, the production, and the manufacturing and the R&D of those chips, and that in and of itself has an extensive domestic supply chain. And what we're looking at here is we're just looking at the domestic benefits. We're actually not even looking at things that are extending beyond the U.S. border, but there is a huge amount of domestic activity that's just tied with the production and design and R&D of chips themselves, and that's where you're seeing a lot of those ripple effects, start to emanate out, at least in the indirect side. On the induced side, the industry itself pays some of the highest wages of any of the industry sectors in the U.S. economy, and when people are paid high wages, they tend to spend more money. They tend to buy, more goods. They buy more services. They have a larger kind of that induced downstream spending effect in the U.S. economy that then supports all the other kind of consumer domestic economy industries that are out there in the U.S. So we start to think about all the home purchases, and when you buy homes, you're buying lumber that's going to be going into building those homes and all that kind of stuff, and that has all these other new cascading value and implications that are tied to the industry itself, which is why you see a lot of these higher multiplicative values.
Yeah, no, that makes a lot of sense. Appreciate that. All right, let's go on to the next slide here.
Yeah. So as I mentioned a couple of slides earlier, we're tracing all these values through the industry sectors that are tied to the semiconductor industry itself. So when we start to think a little bit about the industry employment, and this is just on the job side, not looking at some of the other components, we're just looking at the job side, we see that there's a huge amount of economic activity and industry activity tied to manufacturing for the semiconductor sector. Now, this isn't just a direct semiconductor manufacturing side of that, although it certainly makes up a good proportion of that number, but it's also all the upstream manufacturing of machinery, equipment, and inputs that are going into producing chips as well, and designing chips and all of that that's actually tied. So a huge spectrum of industry and manufacturing activity that it extends or exists because of the production of chips themselves. Another one that I actually wanted to highlight, as well as this large percentage of professional and business services that's actually tied to the semiconductor industry. This is high for really two basic reasons. First is the R&D side of semiconductor activity can actually be how it's found in the industry classification that is connected to professional and business services. When you start to think about all the different types of purchases by R&D, by design, by chip design, and the manufacturing of chips themselves, it supports a huge amount of additional economic activity that's tied just to professional business services and that value add contribution.
All right, next slide.
Yeah, next slide, please.
Okay.
And then lastly, just kind of in terms of our 2020 view, our 2020 baseline, it's always helpful to compare what that impact or what that multiplier value is within the semiconductor industry compared to other industry sectors. So here we see that the semiconductor manufacturing, the semiconductor industry itself has a jobs multiplier of about 6.7. And what this means is for every one job that's in the semiconductor industry, an additional 5 jobs are supported elsewhere in the domestic economy. And the previous slide kind of showed you a little bit more of that distribution of where those jobs are located. But this really starts to give a bit more of a perspective of how does the semiconductor industry stack up against other industry sectors in the economy. And we see that it's highly comparative to the aircraft manufacturing. And part of the reason is aircraft manufacturing, like semiconductors, has pretty extensive supply chains. It's very capital intensive, but it's also labor intensive. And all of that activity, really generates a lot of additional economic value that then, helps to support much broader spectrum of U.S. economy, jobs, and industry sectors overall.
Mm-hmm. Yeah, so you could argue that one semiconductor job comparatively compared to some of the other jobs has like a per unit bigger impact on upstream and downstream jobs than vast majority of many other sectors, just by looking at this, right?
Yeah, absolutely. It's amongst the highest, hands down.
Yeah, great. Well, thanks for that overview on the current situation. Now I want to turn to part of the report that I suspect most folks are probably eager to hear about, which is the impact of the CHIPS Act funding incentives on the domestic manufacturing of semiconductors. So Congress is, as everyone knows, contemplating significant funding incentives to support domestic semiconductor manufacturing activity. We asked you folks to model what the impact of such an incentive program would look like on the U.S. economy, including domestic jobs. So I guess let's find out. What did you guys find out in terms of the impact?
Sure, let's take a look. I think it's a really positive impact, really large impact. And as we'll see on the next slide, we take a slightly different approach than what we did in 2020. And what I mean by that is we don't look at just the semiconductor industry itself. We look at some other activity that would be generated as a result of these incentives. I do, however, want to note that what Hamilton was talking about earlier in terms of using input-output tables and the channels of impact are indeed the same. But here you can see we have kind of 4 different segments that were included. And that includes the R&D activity that goes into kind of designing and laying out a new fab, the construction of that new fab, and then the installation and purchase of equipment that goes into the new fab, and then lastly, kind of ramping up plant operations. And when we look at this, again, a key difference relative to the 2020 impact is we look at this over a 6-year period because not all of this activity occurs during 1 year. This kind of happens at different phases. So we wanted to model that to be reflective of how that activity carries out. The chart on the right, you can kind of see how the different segments come into play. So for example, you'll see the CapEx and the construction tend to occur early on in the period that we looked at, whereas some of the activities such as the ramp up of operations and some of the R&D activity tend to be more pronounced towards the tail end of this time period.
And just to clarify, Mike, so you're looking at this time period 2021 to 2026 because that is really the length of time it takes to build up a fab, or to sort of build and ramp up a fab before it becomes a permanent piece of the new manufacturing base, right?
Right, absolutely. And we, I should note, we talked to some industry experts that were very helpful in thinking about how we modeled this. Even before you break ground on a plant, you have to think about, the architectural designs, how you're going to lay everything out in terms of the footprint of the building. And then, for example, once you have the equipment in there, a fair bit of the CapEx is kind of built around calibrations, getting everything working just right. So that's kind of reflective of, getting these fabs up to a full 100% capacity.
Right. And that's why also the mix of jobs per year changes, right? Because obviously at the beginning, you're going to have construction jobs, but they're not going to last the whole period. The building, the fab will be built, and then there'll be a shift in jobs during this temporary jobs period where you're going to have more operations people who will be doing stuff in the fab to get it ready. And so the mix per year over the sort of the build out the total fluctuates, but also the composition, right?
Yes, absolutely.
Yeah.
And that includes everybody from the construction workers, even the construction workers themselves. You may have the folks who come in and pour a foundation, and then towards the tail end of that construction, you'll have perhaps some HVAC and electrical work done. And then, as I mentioned, you'll have some of those folks who are installing the equipment come in and do some calibrations, and they may be working with some of the folks who deal more on the operational side at the end to kind of bring them into the loop and again, kind of get that up and running without any hitches.
Right. Cool. Should I go to the next slide?
Yeah, let's take a look at the next slide.
Yeah.
So this, I think, is just a high-level summary of some of the impacts. So again, using that same input-output framework, what we've done here is estimated the impact over this 6-year period. And as a result of, we assume the $50 billion federal investment to fund the semiconductor manufacturing incentives would add about 1.1 million jobs to the U.S. economy over the 6-year period. And that would add roughly just under $150 billion to U.S. GDP, so about 147.7 billion. Mm-hmm. This includes, as we mentioned, the direct, indirect, and induced impacts.
Right. But to be clear too, and sort of conceptually to think about it, these jobs, because this is jobs that are helping to build out this new domestic footprint or manufacturing base, they are by definition jobs that are sort of temporary in terms of building out this infrastructure, right? Not to say that there won't be permanent jobs that will then be added to the direct and induced and indirect footprint that Hamilton mentioned that we currently exist in 2020, and it'll likely obviously be larger after this build out phase. But just to be clear, these jobs, this 1.1 total jobs over this period, would be jobs that would come and then after the build out would go, right?
Yeah, you're absolutely right. They are temporary in nature. In that the spending would be done over the 6-year period. But the end result of that, which we will take a look at in a few slides, does increase the footprint of the semiconductor industry itself, which I think is an important thing to note.
Right, yeah. Should I go to the next slide?
Sure, let's take a look.
Okay.
So again, kind of looking at the jobs number here, as we noted, over the 6-year period, the incentive program we estimate would add about 1.1 million jobs to the U.S. economy that otherwise really would not exist as a result of all this spending. Similar to what we saw in 2020, the footprint is concentrated in kind of 2 buckets. The first of which is the manufacturing activity, and I think here manufacturing is the largest share of the jobs. The key difference compared to 2020 is that it accounts for a lot of the CapEx, the need for that new equipment that would be installed in these fabs. So that accounts for almost 1 out of 5 jobs of the total. But also we see a large impact in things like professional and business services. That includes the R&D as well as everything from financial services, getting financing to construct this, any legal services that you might need. And then also I think it's worth pointing out trade, transportation, and utilities sees a big impact. So that would account for kind of all the transportation of goods that would needed to be delivered onto the site, for example. Mm-hmm. And that accounts for about 15% of those total jobs.
All right. Should we move on to the next slide?
Yeah, let's take a look at the next slide.
Okay. All right. Go ahead.
Yeah, as we mentioned here, I don't know, Falon, if you want to talk about this. I know we had quite a bit of back and forth on how to make a apples to apples comparison to the 2020 impacts. Mm-hmm. I think that was pretty important.
Yeah, no, I think, and I think this slide captures it, and I think this is what I was alluding to on your 2 slides ago. There is, in addition to the immediate jobs and GDP and wage impact of of an incentive program for incentivizing domestic manufacturing, separate from that, there is a long-term legacy impact on jobs, on the direct jobs footprint, and on wages and on GDP. Once those fabs are built, right? You built out this fab infrastructure. That's what the $50 billion basically gets and adds into in the U.S. For the domestic industry. But then that footprint is then operating, and there's workers in those fabs who are working. They are also having a indirect upstream impact on jobs now that there are more fabs in the U.S. A downstream impact on induced jobs wherever those fabs may be, with folks respending money for lunch or whatever, or buying a car in whatever new community they're in. So I think it's important to one, recognize the 2 different types of jobs, the nature of the 2 different types of jobs that are being created with this program. One, direct jobs that are temporary from the 50 billion, but then separate from that, legacy enduring impact are, I think, and it's important to underscore that are jobs that are now sort of, I guess, as economists like to talk about, sort of in the long term, going to always exist, right? As long as those fabs are there and are operating, there's going to be new jobs that have been created, so that the industry in some ways has permanently expanded, and therefore more jobs have expanded and more GDP impact in the U.S. compared to if those fabs were built abroad, right? So those fabs are going to be built somewhere. Because the market is growing, the long-term market trends are growing. Question is, if they're built in the U.S., then those jobs and that economic impact is going to occur directly in the U.S. If they're built abroad. Then they won't occur obviously in the U.S. and obviously we want them to occur in the U.S. So I think this is a really instructive slide because I think again it shows that we move from 277,000 jobs, direct jobs currently to after the build out phase, after the 6-year build out phase and the impact of the $50 billion incentive program of actually going to 319,000 jobs, direct jobs impact. And of course that then increases the jobs, indirect and induced jobs to, correct me if I'm wrong, Hamilton, but goes from 1.85 to 2.13 million jobs, right? Or Mike?
Yeah, you're absolutely right. That would be the new estimated total impact of the semiconductor industry itself. Assuming a similar jobs multiplier of 6.7.
Right.
And I think you make a great point too, Flan, is that this is really a result of building the fabs here in the U.S. What this modeling does not do, and this is a key distinction, it does not account for activity that's occurring outside of the U.S. So all of these jobs, all of this value that is created by this activity, either in the build out phase or in the enduring phase, is all US based, which I think is really important.
And also too, I think something to underscore, and you guys can confirm this, is that there is no more additional spending after the 50 billion is spent that accounts for the added 42,000 jobs, right? That's just something that's a legacy, a positive legacy impact of the initial investment and build out, and then it just sort of, then because those fabs are in the U.S. employing people every year to operate and upstream and downstream impacts, that's again just a legacy of the actual build out that would occur post after the fabs are built, right?
Yeah, absolutely right. And another key distinction here in kind of this perspective is, starting in 2027, you kind of assume that year in and year out, these folks are going to be going into these new fabs or the existing fabs and, producing chips because, frankly, we need them for almost everything in the economy these days.
Yeah.
Whereas the build out phase, certainly are significant and important jobs, but once you construct a new building, the project is over, right? Once it's done, they're going to go on and maybe work on a new building for another industry. So we're not attributing the enduring impacts of the build out phase. But here, I think that's the key distinction is there's going to be a continued demand for chips. And this is really the workforce that would support that year in and year out.
Right. Yeah. All right, cool. I want to go to the next slide because you did allude to the impact more, or the demand, I suppose, more broadly in other sectors, downstream sectors. And we did ask you folks to sort of delve into the numbers and look into sort of what are and how many sectors downstream rely in some ways on semiconductors. So I thought this was pretty helpful, and this is included in the report. Can you just talk a little bit about what this shows?
Sure, absolutely. So first, we looked at the input-output tables again, and we use this as a way to trace other industries that are making purchases from the semiconductor industry as inputs for their goods. So for example, when you're making a car or a cell phone, you need chips. They're going to go to the semiconductor industry and say, hey, can you make some more chips for us? We're going to purchase X amount for you. And so we found that over 300 different industries were making purchases that go into their goods. It is worth noting that these are only industries that are making direct purchases of semiconductor chips. And what I mean by that is it actually doesn't account for things like if say a professional services firm buys a computer, they're not directly buying a chip. So in many ways, you can imagine nearly every industry is touching a semiconductor chip in some way in terms of their operations and the needs. But this is really looking at those direct purchases.
Right. If you were to include, and just because I know because I read the report, but that's 300 plus sectors out of only like 500 and some, right? So it's the vast majority of sectors that you looked at in the US economy that are actually in some way or another purchasing chips for their own consumption or production, right?
Yeah, it is a clear majority. It's out of, I believe, about 546 in terms of the detail that we looked at. And what we did here was actually we were able to sum up the workforce size of those 300 plus industries, and we found that about 26.5 million jobs in some way rely on semiconductor chips as inputs for their production process.
Wow.
And so this does not include the semiconductor industry itself. This is kind of a different perspective in terms of how semiconductors are used throughout the economy.
And are important throughout the economy in some ways, helping to enable other downstream sectors, right? Yeah.
Correct.
And I know you folks didn't run the numbers, but I suppose to your other point earlier, if you were to include purchases of computers or other electronic systems in the sectors that are consuming both chips directly and those products that are again powered by chips like a computer, right? Then that 300 plus sectors would likely be much higher even.
It would be close to nearly all. I think these days, in order to operate in the modern economy, you need a lot of the technology, whether it be a cell phone, a computer, even a vehicle. A lot of the different types of machinery these days all include semiconductor chips. So, I think you're absolutely right. You can imagine in many ways, I think our lives really rely on semiconductor chips.
Mm-hmm. Correct. Yeah. Awesome. Well, this is great. I know we have a whole other section I want to get to. So, and you guys did a whole bunch of other work that sort of profiling the industry. So why don't we delve into that? Because I think that's also super important to look into. So can we go to the next slide?
Yes, let's do that.
Okay. Oh, go ahead.
Sure. So this first one, as I think Falon and Hamilton alluded to earlier, looks at the workforce composition in terms of kind of those broad buckets. This breaks out the total direct jobs number, which is the 277,000 in 2020 that we're looking at, into the manufacturing bucket and then the fabless semiconductor design firm bucket. Mm-hmm. So you can see the manufacturing bucket there is slightly larger, counts for about 2/3 of the total jobs at about 185,000, whereas the fabless design workforce was about 1/3, around 92,000 jobs.
Mm-hmm. And this getting back to sort of the commentary I provided earlier at the start, again, we're using BLS data. But as many folks who may be on the call, maybe on the webinar know, BLS does not actually pick up jobs from the fabless semiconductor component of the industry. So that's where, again, working with companies on the data, on surveys and reaching out, which has really been helpful, because that is something that it's sort of a hole in what the BLS is able to capture. We've been working, it's a long story. We've been trying to work with them for many years to include the fabless semiconductor design subsegment and all their jobs and all their economic benefits in their numbers, but have not been successful to date. So therefore, we have to do this sort of manually. But again, working with companies, we're able to, I think, get the best possible number and estimate for that. And I think we're pretty good, feel pretty good about that. So, all right, just wanted to say that. You want to go to the next slide?
Yeah, let's take a look at the next slide.
Okay.
So another piece that we did look at was the geographic distribution in terms of state. And we did this in two ways. The first is looking at it in terms of volume in each state. I think it should be no surprise that some of the largest states included California, Texas, and Oregon. But you can see here, we picked out the top 15 across the US. And then if we want to jump to the next slide, we also looked at it in a slightly different way. This is a measure I like to use a lot. It's called a location quotient. and it's a bit more of a relative measure. So it's less about volume and more about the concentration of the semiconductor workforce in a given state compared to the US overall. And so we wanted to highlight those states that indicated an above average concentration of the semiconductor workforce. And you can see here, Oregon really stands out as being the most concentrated. It's almost 11 times more concentrated than the US average. And it kind of highlights the fact that maybe other states, while they don't have the same volume as a place like Texas or California, certainly rely on the industry itself for their state or local economies. And that includes places like Arizona and Idaho and New Mexico, for example.
Right, yeah. All right, move on to the next slide.
Sure, let's take a look. Another piece of the workforce profile that we looked at was the occupational profile. This looks at the types of jobs that are employed within the industry. And, I think one of the key things that we found here is when people think about semiconductors, you probably think high tech, a lot of engineering and maybe some amount of computer programming jobs, but there are a significant share of production workers within the industry. And in fact, they are the largest represented group. And then when you add in the engineering jobs, that accounts for about actually over half of the total jobs within the industry. But you can see here that all of the different job functions are important for the semiconductor industry itself to operate on a day-to-day basis. And that includes everything from your business analysts, your management, even, for example, production or protective services, which might provide security, for example.
Yeah, no, I think that's a good point to underscore about how, yes, the semiconductor industry is part of tech, but in some ways is quite unique in that it has such a high manufacturing share or job composition that is based on manufacturing, given and precisely because a lot of the manufacturing, there is a base in the U.S. We need to increase it, I think. But that those to operate a fab, requires a lot of production jobs, a lot of people on the floor, and to basically do the manufacturing, because it's a manufacturing activity. So just want to underscore that.
Yeah, and I think we'll see on the next slide or in two slides. This is actually a great slide to understand here is that because of all of those production jobs, predominantly, you're providing opportunities to folks who maybe haven't gone on to college and gotten a bachelor's degree or an advanced degree in engineering. You're still providing opportunities for employment, and across the educational attainment spectrum within the semiconductor industry, all of those folks are earning higher wages than they would otherwise when compared to other industries of the economy. You can see, for example, folks who've only obtained, for example, a high school diploma earn about 40% more than they would in other segments of the economy. You can see here it's probably most pronounced in the bachelor's degree area, where it's closer to 80% premium relative to other bachelor degree holders elsewhere in the economy.
That's interesting finding. I mean, it's interesting that it's across the board, no matter what level of education you currently have. You could argue that getting a job in the semiconductor industry will pays better than in any other industry that you would qualify given your educational level, right?
Right, and I think it's just reflective of the skills and the knowledge that you need to be successful in the industry. It's a very high tech industry, and regardless of your educational background, you still need to know quite a bit in order to successfully produce a chip, and it's really a team effort.
And I also think, just chime in real quick, I think it's also very reflective of the productive value that's associated with the industry across the entire skill spectrum as well. And that's being reflected in the wages that you're seeing.
Mm-hmm. That is production per worker kind of thing?
Exactly, yeah.
Yeah, mm-hmm. Totally. All right, should we go to the next slide?
Yeah, let's take a look. I think we have a few additional socioeconomic measures here. Again, we're looking at the semiconductor industry compared to all other industries of here in the U.S. And this one looks at the race ethnicity profile. And I think where the semiconductor industry stands out is its ability to employ non-white workers. It shows that just under half of the workers within the semiconductor industry are non-white. This compares to kind of all other sectors being closer to maybe 40%. So I think in terms of some of the diversity and inclusion programs that we mentioned in the report, those are certainly working for the semiconductor industry.
Yeah, I would say that there are some areas, and we talked about this on a previous webinar that we did that highlighted diversity and inclusion efforts that the industry is undertaking. That there's still some areas that the industry acknowledges that they are working on. Certainly, African American their share of African American workers is much lower than the average, and in other areas too, Hispanic. So I think the report does a good job of highlighting efforts that the industry is doing to quite frankly shore up those areas and be more reflective of the overall sort of U.S. Diverse workforce. But no, it's helpful to have this information. Should we go to the next one?
Sure, let's take a look. This one is related to some of the wage premiums that we're looking at earlier, but this is really showing the educational distribution of the workforce compared to all other industries. And you can see the semiconductor industry on the top there is quite unique in that it has a really high share of folks who have a graduate degree. I think that's reflective of kind of what we were talking about earlier in terms of the skills, the specialized skills and the knowledge needed that goes into all of the engineering and the design component. So a lot of those graduate degrees are going to be found in those engineering occupations. Mm-hmm. On the other end of the spectrum, though, you still have about 1 in 5 workers in the industry who only have perhaps a high school diploma or below. And those workers are primarily employed in those production jobs. So the industry itself is providing opportunities for workers who don't have that college degree to really earn those family sustaining wages. And I think that's an important distinction to make when comparing to other industries is the wage premium is represented across the educational spectrum.
Right. And also if you were to compare semiconductors like we were talking about before to maybe other parts of tech, the blue high school and below may be even smaller, and the bachelor's and graduate degree segments of those parts of tech could even be bigger. Mm-hmm. So kind of unique within tech, obviously not as strong as in terms of manufacturing, all other in terms of share that are employed with high school degrees or below, but still something. So all right, let me see, do we have another slide? Just the wrap up slide, I suppose.
Yeah, that wraps up. And I would like to highlight the fact that we have additional measures in the report, and I think it's definitely worth a read to see some of those other comparisons that we have to offer.
Yes, and you guys have it on your website. I know we have it on our website. I'll go ahead and let people know we have it at www.semiconductors.org, and you guys have it on your general homepage, or if you just search Oxford Economics.
Yes, that's www.oxfordeconomics.com.
Okay, great. Yes, and again, the report couldn't be more timely. I think we are, it's certainly the part about the impact of the potential $50 billion incentive program on domestic jobs and GDP. I really appreciate the work that you guys have done to put this together and really sort of put some numbers on what that impact in particular and what the current impact is, and also the various channels and how all this comes together. We have a bit of time, about 10 more minutes left for some Q&A, and I would encourage folks, if they have, if they can, to sort of submit a question using the Q&A button. You can just hit the button and submit a question. Before we get into to kick it off, let me just ask a sort of just a general question. I know you guys cover a lot of different industries, work on different projects. As sort of a neophyte or someone new before this project started to the semiconductor industry, is there anything that stands out to you now having spent several weeks looking at the semiconductor industry and its impacts in terms of jobs and GDP in the US, of how it compares to other industries in terms of its economic impact, just broadly, or any thoughts on that?
Yeah, I'll kick one off, and if Mike has any other things to feed into this, I think what we see is something that's very characteristic of a very high value, high level of production and integrated supply chain type of industry sector, where you see a high level of supply chain activity that's domestic within the U.S. economy, that's driving very, very high multipliers and values. I think, for the semiconductor industry itself, because you have kind of this two-sided aspect of the industry, where you have a very integrated domestic supply chain and very, very high wages, you're pumping a lot of additional new multiplicative value into the U.S. economy that kind of holds the industry much higher above a lot of other economic activity or other industry sectors in the U.S. that might have kind of either distributed supply chains that are a bit more international, or might have lower wages associated to it that are creating a lot of the downstream economic value. So when we've done these studies for other groups, I've seen this multiplier value is probably amongst the highest that we've seen for when it comes to manufacturing in particular, and that includes a lot of the other types of advanced manufacturing economic assessments that we've done in the past. And not to brag or anything, but having lived in Boise for a very long time, I'm very appreciative of the role that the semiconductor manufacturing industry actually does to really prop up local economies and state economies. And we saw Idaho on the map as being something that is the state's heavily economically reliant on the semiconductor industry for just economic value being generated within the state itself. And so it's another aspect that's kind of worth flagging. But Mike, do you have anything else?
I'd just reiterate the fact that, the workers in the industry itself are highly productive, and, that's reflected by the high wages that are paid. And to your point, Hamilton, when they go out in their local economies, a lot of that consumer spending is done right in their local communities, and that helps support everything from barbershops to grocery stores to your local auto dealer. So, having these jobs located here in the U.S. doesn't just benefit the industry itself, it's benefiting a whole host of other industries.
A lot of Main Street activities. Yeah,
absolutely.
Yeah. All right, cool. We have a question here about the multipliers. You were mentioning the multipliers, and comparatively speaking, how the semiconductor industry has a pretty high multiplier. Let me just go back to the screen where we show the comparative sort of look at the various multipliers and where the semiconductor industry fits in. I guess the question is, how does the semiconductor industry compare to the overall auto industry multiplier? I think the auto industry is here, motor vehicle parts, maybe in a couple places, motor vehicle body manufacturing. I'm not familiar exactly with sort of the ins and outs of sort of the auto sector manufacturing, how it's categorized in Implam, but I guess the question is, what would the overall automotive industry manufacturing multiplier be? I suspect it's still pretty high if you look at both of those two, not as high as the semiconductor manufacturing, but I think the point being, from what I understand, manufacturing, whether it's semiconductors or autos or aircraft, will naturally have high indirect impact, right? Because again, they're pulling in a lot of capital, whether it's auto parts or whether it's semiconductor manufacturing equipment, or whether it's airline, I don't know what, like seats for airlines. There's a lot of upstream activity that has to occur to supply those manufacturing industries by virtue of the parts, compared to, say, a services sector or amusement parks and arcades, or something that is, or doesn't require that high capital intensive sort of need. I guess the question, though, is on the other side, the induced, the semiconductor industry does have pretty high wages overall, on average, they vary depending on educational level and the occupation. But I wonder if there's any breakdown that you would know of comparing some of the other manufacturing sectors in terms of upstream and downstream induced impacts, and maybe specifically with the auto sector as well.
Yeah, I think there's kind of two issues here. So the motor vehicle, the automotive industry is kind of broken into a lot of its component parts, and up to and including kind of that final assembly of vehicles. So the way that the implant breaks out, you end up having about 4 or 5 different industry sectors that are all tied to the production of automobiles in the U.S. I think it's important to make a very clear distinction that when we're talking about these multiplier values, these are not additive across all automotive manufacturing. So you're not going to add motor vehicle parts manufacturing to motor vehicle body manufacturing to have some sort of a multiplier that's in excess of 10. Because each of those components are just kind of part of the supply chain inputs into the final production of a motor vehicle. So you're still kind of dealing with this this value-added manufacturing piece. We didn't calculate a full automotive industry sector economic multiplier just because that would have been a few additional sets of input-output acrobatics that we would have done in order to calculate that. And it really wasn't what our focus was. What we're really looking to do is get a really good sense of what the multiplicative value of semiconductors looks like. And then, because we have some of these other industry sectors that are fingertips in the implant system, we kind of pull those out and just kind of compare them industry sector to industry sector rather than kind of summing together and then kind of separating out just the value add components of the full automotive industry sector overall. But you're absolutely right. The wages that are being paid in semiconductors are generally an order of magnitude higher than what's being paid in the automotive sector. So you're seeing a lot more of those induced value and impacts being driven a lot higher on that multiplicative scale side of things. But yeah, that's you gave a pretty good summary overall of what the ins and outs are there. But Mike, I didn't know if you had anything else from your side.
Yeah, another thing to consider is the supply chain spending and where that takes place. That certainly affects the magnitude of the multiplier. So you can imagine an industry that purchases more of its inputs domestically, here in the U.S., that's going to lead to a higher multiplier compared to industries that purchase inputs from overseas. That is, they import a lot of their inputs.
Right, and I know the the semiconductor manufacturing equipment sector. The U.S. is very, very strong in that. A lot of major companies in that sector are U.S. headquartered and U.S. based. And in fact, for many years, just as an aside, because I worked on sort of trade issues, the U.S. has always maintained a trade surplus when it comes to semiconductor manufacturing equipment for many years. And I think that's indicative of the fact that there is a lot of manufacturing of that equipment, to your point, Mike, here in the U.S. That is, again, driving more jobs and more economic activity from the purchases of those equipments here in the United States by the semiconductor industry. So. I know we have a couple other questions, but I also am very sensitive about being sure we end on time. So I think we're just going to have to end it there. I know we're a minute out, but I want to go ahead and thank you, Mike Reed, Hamilton Galloway. Again, thank you so much for participating in today's webinar. And again, thank you for working on this report. I think the findings are very, very helpful and robust. And I think we'll be continuing to look at these numbers and think about them, especially in the context of their impacts on the CHIPS Act funding side. So again, I encourage everyone to read the report, www.semiconductors.org. And again, Hamilton and Mike, thank you very much for joining us today.
Thanks for having us.
Thanks for having us. Appreciate it.
All right. Thank you.